Requirements management is a key to ensuring that engineering teams follow the documentation, the analysis, and the prioritization of the requirements at every stage of project, right? Let's see our agenda. So we start talking about the challenges, why traceability matter. And we're moving to verification and validation process. We'll talk about the model and model-based design so we can work together. Okay, how to create and define requirements in MATLAB and Simulink environment. How can we visualize, how can we do the link, create this linking requirements in Simulink? Okay, how can we import requirements from third-party applications, such as doors? We have a demonstration here using the requirements from doors. And then we're talking about the standards compliance and then how can we identify design errors in our project, in our models. Okay, we have tools to cover all these topics. And then we can talk about the summary. And if you have any questions, please let me know. Okay, thank you again for your time. Let's start to talk about the challenge. The requirements are initially captured using tests, and the test requirements can be ambiguous, incomplete, inconsistent. You can see here, for example, in the Word doc, we have a text, right? And sometimes it's hard to identify and to create this link in our models. So basically managing the many activities in the artifact is needed to meet the certification standards. It's hard. While following this reference workflow, there are many artifacts that you need to manage along the way. So it's very challenging to manage all the activities and the artifacts and determine when the test is complete. It's really complete. So you can see here the requirements, the design, the code, and then the target. Okay, it's very challenging in terms of managing all these stages. Why traceability matters? So the customers use requirements traceability to ensure the application meets all the requirements and is fully tested. You can quickly find the code that implements our tests or a requirement and understand the impact of a change to respond quickly. It's important to understand all this impact. And the certification standards require traceability to show where each requirement is implemented and tested, right? It's really, really important. So here you can see the verification and validation workflow. It starts with requirements. So we often start out in text form, an idea, but the customers increasingly choose to model these requirements. During the development cycle, you need to ensure the traceability to requirements. So you can see this, the first step, user requirements, the system requirements, the model that you can see the checks, the compliance, the source code. If you have many domains such as electrification, electronics, pneumatic, and others, multi-domains working together, you need to check, you need to see all this process together. And the object code, okay? So the requirements management is a process that involves the planning, monitoring and controlling all these requirements from their initial requirements, identification through to the final implementation and validation, such as generate code or this implementation with hardening the loop, for example. Let's talk about model-based design. I don't know if you know, but it's really interesting to know this approach, this methodology. Model-based design is a strong approach for engineering complex systems. You can use model-based design with a MATLAB and Simulink to shorten development cycles and reduce your development time. Okay. In summary, you can use model-based design. You can modeling to try new ideas, run the simulations to perform fast and repeatable tests. And the automation basically helps you to eliminate manual steps. Okay, with a model-based design, you can apply all this process using MATLAB and Simulink. Okay, Fernanda, but we talk about model-based system engineering, we talk about the requirements management. Why model-based design? Because model-based design with verification and validation process, you can work together. You can use all these capabilities in MATLAB and Simulink environment. Okay. So how can we developer be sure and answer all these questions? Are all requirements implemented? So how are they tested? Why is this function here? So usually the consumer use, the developer use the external requirements. It's really common. So from Doors, Siemens, Polarion, so PTC, JAMA software, we have many options to apply and to work with these requirements. If you are using requirements in another tool, then there is an import operations for Word, Excel, Doors, and support for the standard requirements, such as interchange format, REC-IF. We talk about it after that. You can also author requirements where the source of requirements and Simulink, such as requirements table. Okay. And with requirements part of this development environment, it's very easy to create this link between requirements and architecture, design, test, and implementation code. Okay? You can create this link to other tools from traceability from this environment in MATLAB and Simulink. Okay, covered analysis to show where there are gap in implementation testing, and there is no problem if the requirements change in the external tool. Okay, you can change it here and see the impact in your design. Okay. Fernanda, how can we visualize the requirements in MATLAB? We have two main views in MATLAB, perspective and editor. Okay, so the perspective provides an integrated view, combining requirements and the model together. And the editor is a standalone app that allows you to manage all the requirements within your project. So you can see with more details. Okay. We have an example, you can see the image, the tags, the links, the implementation, the ID, the summary for a specific requirement. The start of process begins with requirements. So requirements typically come from our external tools. Okay, we can import from Microsoft Word, Excel, IBM Doors, and Doors Next, or REC-IF standard. Okay. So you can integrate and you can use all these capabilities easily with MATLAB and Simulink, and you can export as well. Another capability here is requirements to box maps using regIF. You can create a link types and attribute to the requirement to box. So basically, after you import these requirements, you can edit the type and attribute mapping, so you can customize your requirements. Okay. I can share with you all these details, but you can see here the provision from Vector, Clarion from Siemens, IBM, from, Doors from IBM, JAMA, and generic import. Okay. So here we have a demonstration using system requirements RL4 and Doors. So for this demo, we will start to see how can we include the description, image, and all this status in MATLAB. Okay. So here is a requirement editor. Okay. You can use import. You can select the document type. In this case, it's IBM Rational Doors. You can select the parameters such as the location, want to include callbacks, you can do it. And that we have all requirements from Doors. Okay, for Doors you can configure options, the import such as graphics, filter, its scope. Okay, you can control how and which attributes to import with the mapping dialog. Now, with the requirements imported, I can now work with while the Simulink and System Composer environment. You can see here the boxes, and these are from System Composer toolbox. Okay, and a browser appears. Let me show you the perspective requirements in your model, and we can create a link, drag and drop your requirement. So you can see here, again, the pilot input signal. There is no link. We can drag and drop in your block. You can see the block has linked, and you can see a summary weight requirement that this block refers. Okay. You can select the port to see exactly the requirements that you want to add. Okay, let's show one more time. This is a requirements app and using Simulink and System Composer, sorry. It's another way to add. Okay, that's good. So we can see the bidirectional navigation between the requirements, design, and the generate code. So we have an example, the model, we can see a suite block and Simulink. You can see exactly the line after it generate code, and we can see the link and requirements environment, the requirements app. Another thing it's very good to identify here in requirements editor is to see the overall status in how can we identify the gaps. You can display the implementation and verification status. Okay, for the implementation status, the blue indicates that a link exists. The light blue is a kind of justification, okay, of this implemented. And the blank indicates that a link is missing. For verification status, the green indicates that the test passed after our test has run. And red indicates a failure, and the yellow indicates there is no result for that. And the blank indicates that a link to a test is missing. Okay, it's really interesting to know about these details. A missing test for this requirement is visible by this gap and a verification status. The new traceability matrix available, I think, 4 years ago, 3 years ago, I'm not sure, but it's really good because you can see if there is any gap. Let's see one example here. So we are using a traceability matrix, okay? We can select the requirements on the left side, and the top, we can select our data from this model. So you can see here, the filters are available to manage all this data. The links between the items can be added directly in the matrix. Okay, you can see this gap and create this link. The verification stats reflect that the link, okay, so you can see it's covered now. Let's see it one more time. Selected the top side. So if you want to select a test case or test file or test suite, great, easily. Changes, it's really important because during all this project, it's really common to do these changes. So changes are bound to happen in the project. If there is a change to the requirements linked to the design, that can be impacted links are they highlighted in the model. Okay, you can navigate in this block and check this impact. So you can see here one example. I changed this value from the doors. So we have our requirement here. I'm changing the verification method, the status, the text, and I want to see what is the impact. We have the update button, and we can see easily we have changes in our requirements. In traceability diagram, we can see exactly. block as well. You can see. You have traceability, you have documentation. You can see the impact. Okay. We have another example using, sorry, stop. We have another example providing this step through the verification and validation activities using UAV package. And in this example, you can see how the requirements are linked to model components and test case. So we were talking about this test, but Fernanda, how can we do that? Okay, we can see this test manager app and Simulink test. Show you. It's a good interface, shows the overview of the requirements allocation. Do you remember? How can we access, sorry, how can we access the requirements? Select and check the block, the requirements are in. Have a good visualization. Now in Task Manager app, you can create your test. Test Manager is a tool from Simulink Test, okay, is used to configure the automated testing and evaluation of the result. You can see some of these results. An interface shows the overview of the requirements allocation along with the test results, which includes verification status, which green and red bars indicate passing or failing, okay? This is a great example that you can utilize to get the start in this implementation for verification and validation workflows. Okay, if you want to see and to explore exactly this demonstration, I can share with you. Okay. Fernanda, what is the capabilities to identify these errors during the project and during the design and during the verification validation process? So with requirement toolbox and Simulink Design Verify, you can use formal methods to identify hidden design errors in the model. It's really important here because it's a hard task to identify this error manually. Okay, so basically with Design Verify, you can uncover hard to find this logic and design flows. So you can identify, you can see red it's error and green it's a valid block. For test generation, you can automate this test, okay, to analyze this missing coverage. So we can work for 100% to cover all these tests and check if my model in terms of logic, in terms of standards, okay. And property proving, you can prove the design meets with the requirements. So we can see here exactly if my requirements, it's okay or not okay. We can generate this report, okay? you can find and fix these errors, not only to identify these errors. You can fix these errors using the design verify. Okay, so you can detect, use automatically generate test case to cover all this and fix all these errors early. Okay. And to do that manually, we know it's hard. It's hard. Another capability I believe it's really interesting here is work with the Simulink tag block set. You can analyze your model to verify that it complies with the industry standards. So, and modeling all these guidelines. If you want to check all these standards as a standard, if you want to check your model, your requirements, your logic, your stateful and Simulink and MATLAB models, you can use these two to check all these important standards and process. Okay, so we have here the standards and guideline checks for automated. This standards compliance. You can see exactly the detail of your block, your code. What should I improve? So you can see some guides, some examples, some tips. Okay, you can find and fix these issues while you design. Okay, and you customize checks. The dashboards, you have dashboards, you can generate a report. After that, you have here the model refactoring. You can find the clones and modeling patterns. Maybe it happens during the processing. And the model slice. You can simplify the models to isolate behavior. Okay, we have one example using Simulink test with a test harness. Test harness, you can create a unit test, integrate a code, a specific code, isolate an individual block. Okay, you can test and create many scenarios to check and to verify if the logic is correct. Okay. So I have one example to show you and MATLAB. So here we have a Simulink project. As you know, we can manage this using Git, SVN. It's really good when you have a huge team with many developers. Okay. So, and we have our folders, our data, documents, modules, scripts from MATLAB, and the tests. Okay. Let me show you Simulink. So you can see, also this one. I have this example. It's related cruise control. I don't know if you know. It's a feature on some vehicles that allows the driver to take their foot off the accelerator. So while the onboard computer maintains the vehicle speed. So we have a controller. Basically, it's a controller. Okay. So you can see here the requirements. Do you remember? We can see from here. The specification, the throw value, the target speed. It's really important here. Okay, Fernanda, I want to see. My God. I want to see more details. What is the ID, the status, the verification, the summary? We can open our requirements editor. We have a new window, you can see, with more details. Okay. See here the ID, summary, the implemented column, the username, okay, the type, and the verified. But where is the colors, Fernanda? Okay, I show you. Here we have the test harness. What is that? It's provided from a Simulink test. We can create exactly the same model that I have. You can see here. This is my Simulink model. And this is my harness test. Again, the test harness, you can isolate an individual block or blocks, okay, to create a unit test. You can modify the input to check in specific logic, okay? So let me open this block. Here you can see the scenarios. We have the target speed, the throw values, and we want to check this status is false. This status is true. So I want to run these two scenarios and check my test case. Okay. We have here our test case using Test Manager app. Okay. How can we compare? We have our Simulink model with my main model, and we have the harness. Here, I can play, I can create many scenarios, I can create many steps, I can create many inputs and check is the status is false or true. Okay, so we have 4 test cases. Let's run. See more details. You can see graphs. We can create a report. Verification, validation report. I can get my name, MATLAB figures, and create. You can see date, the time. It's one test case, but we can run all these test scenarios. Okay. Apart from Test Manager. Okay, but we can create a report from others apps, from the others apps. I want to show you Simulink, the requirements editor. Do you remember we don't have implemented column, we don't have colors here in verified. I want to refresh. Now we can see the details here. We can see all the functional requirements are verified. Okay. Do you remember when we were talking about design and verify? We can generate this check app just to show you design verifier. Okay, it's running now. You can see it's in progress. It's running. Checking all this trigger input, logic. Almost there. You are working with verification, validation process. I really recommend this toolbox. See, I have details, report, if you want to create another harness model. This report. See, the blocks are green. See all these blocks. Line verify report. You can see exactly the name of my controller. You can see table contents. You have here traceability. You have documentation. Okay. Just pass fast, but I think it's good. Okay. Another thing that I want to share with you guys is tech consistency. What is that? I'm created a controller for a vehicle, right? We have a standard for automotive area, for aerospace as well, for the code. You can see here BISHA, but in this case, I created a controller for a vehicle. So can we check with ISO 26262? Yes, let me check. So we can run these tags. If I'm developing as a standard guideline, okay. This is another toolbox, this is a Simulink tag, okay. The previous one was design verify toolbox. Now let's see. You can see the check saved, code optimization, small controller. So you can imagine develop a cute controller for safety. For complex systems, this is really useful. Okay, I have my controller, cruise controller, and just to share with you, I'm selected only ISO 26262, but you can select another one, okay? If you want to check the specific guidelines, you can do it, okay? So you can see here, 1, incomplete, in terms of standard, 40, warning, and 70, passed. Let's see the report. Tests, save. Where is my MATLAB? See the report. To show you. Where is my, okay, here we are. So Model Divisor report is the name of the app, okay. Here we have a summary, okay, with all these details. Let me go down, see all the tests and checks. The systems. Okay, you can see all these checks. It's passed. Why is passed? Okay, you can see the warnings. This is really good because you can see exactly the block, the parameter, and we have actions here. Okay, recommended action. So specify port dimension for this listed imported. So you can see, you can identify the warning, and you have here some advice, some tips. Okay. Let's go back our presentation. Do you have any questions? Please let me know if you want to share in the chat, please. In summary, the requirements, it's a key of all project. If you can manage the requirements, you have a good managing, you have good visualization of all these states of the project. Okay, the requirements toolbox provide the author import requirements from third-party external tools. If you want to create into the MATLAB, you can do it. Okay. You have traceability, you can identify the gaps, you can see the changes easily. Okay, this is the most important here. In terms of user stories, customer stories, we have here the Continental. It's a huge company. We can see here the challenge is design this controller for suspension. Okay, air suspensions, ECAS, for a half-dirt truck. What was the solution? They used MATLAB, Simulink, all these tools to generate this code to model this air suspension. Okay, what are the results? 6 months of hardware development effort eliminated. The verification time cut by up to 50%. So you can imagine it. 90% of application automatically code. This is really, really good. And we have another user story with Alenia Armarchi, it's an Italian company. They developed this using the DO 178 B-Level A certification, okay, for autopilot systems. And they used model-based design to create the software design, to verify the requirements covered, to generate code, and produce this report, produce this traceability, okay? The results, we can see the requirements review for certification up to 30% shorter, time to flight reduced by 20%, and low-level certification activities automated. Here I can share with you the products just for curiosity, but if you want to know more details about these user stories, I can share with you.